All right, my name's Adam, and here's how I solved their urinal problem. So now, Adam, you may be asking, what the hell are you talking about? Well, let's say you go into your urinal and you come across this kind of situation, huh? What do? Exactly. Now I have the solution to your situations. I have the solution to all of your problems. But let's get started. Here's my debrief. I graduated from Harvard and I had a PhD in urinal studies. I'm currently teaching at Cambridge to young men aspiring to save urinals. I published 3 separate textbooks, each very, very prestigious. So, when it comes to urinals, I, in all modesty, know what I'm talking about. So, one of the postulates that we're going to go of is the 2 urinal postulate, which is saying that you want to avoid having one urinal of separation between another guy. I'll explain what that really means later. And we also have the other guy postulate that whenever you're doing your business, another guy is coming in. Here's a 5 urinal system. And I numbered each urinal 1, 2, 3, 4, and 5. Now we're going to go off of the idea of reflection. So going to space 1 in an empty urinal would just be the same as going to space 5. Pretty straightforward. So let's start with scenario 1. We have a guy in slot 1. What are we going to do? Well, immediately when your sorry ass comes over here, you could eliminate slot 2 and slot 3. Because remember, the 2 urinal postulate. So now we have slot 4 and slot 5 remaining as a good idea. Let's call this going to slot 4, scenario 1, solution 1. And when the other guy comes in, he's going to come across a dilemma too. He's going to either go to 2, 3, or 5. So, if you were in the shoes of that other guy, where would you go? Would you rather be next to one person and be one space away from another? Or would you rather just be next to one and then have the other in the entire different country? Exactly. So he would eliminate 2 and 3 and go to 5. Now let's say we go to slot 5 instead. When the other guy comes along, he's going to immediately think to go to slot 3. So that means slot 5 is our ideal solution to this scenario. Now here's scenario 2. Let's say we have a guy in the middle. What are we going to do now? Well, we can immediately eliminate slot 1, 2, 4, and 5. So that means every slot is eliminated. So what do? Well, we have to split the losses. So would you rather be next to one guy very closely or have a space between them? Exactly, a space between them. So that means the solution is slot 1 or slot 5. They both work. All right. For my 7 years of studying this exact topic, I've formulated a solution such that you're minimizing the distance to the other guys. So if you're not inclined in the mathematics, this is what it means. Let's take a look at 1 over the distance from guy 1 plus 1 over the distance from guy 2, and then just sum all of those reciprocals up. ... That's what it means. Very basic, very simple. You could plug it into a calculator if you want. That's what I did. So here, let's try to apply it into a real-world scenario because this is very useful on many occasions. At least 30 times I've come across scenario 4. So let's apply the distance optimizing value. Remember, we're trying to minimize it. So let's see, we go to slot 2. We sum up the distance between us and guy 1, right? And then we take the reciprocal of that, which is just 1. And then we take the difference between us and guy 4, which is 2. So then that gets 0.5. Sum them up and get 1.5. Same applies for solution 2, and we also get 1.5. Lastly, solution 3, we get 1.25. Therefore, scenario 4's ideal solution is to go to slot 5. Very, very straightforward. Very nice. However, there are some flaws. You did a good job, but there are some flaws. Let's look at scenario 5 right here. We have a guy in slot 1 and a guy in slot 5. Due to the polarization of this, we know that going to slot 2 is pretty much just the same as going to slot 4. So let's see solution 1, going to slot 2. This would actually make a lot of sense because when the other guy comes in, he's not going to go to slot 3 because that's too close. So he would go to slot 4. That means going to slot 2 has one guy not right next to you and another guy on a different island, right? They're in Russia. So now, let's go to solution 2, where you go to slot 3. When the other guy comes over, he's going to go to slot 2. Remember, since you're going in the middle, going to slot 2 is the same as going to slot 4. So now you have 2 guys really close to you and 1 guy on another island. I don't like this. Therefore, our ideal solutions are to go to slot 2 or slot 4. Now let's try to apply the distance optimizing value. Let's say you want to go to a place where the distance between the other people is minimized. So if we take slot 2, solution 1, you get 1.33. But if you take for solution 2, you get exactly 1. Therefore, solution 2 is our ideal solution. But that contradicts what we said before. And we know before weighs more than this distance optimizing value because, as said before, we know another guy's coming. So this doesn't work because you're undermining the fact that another guy is coming while you're doing your business. But remember, even though it seems hopeless, as one wise man said, even in the darkest of hours, there's always light. Man, I'm sorry, bro. Like my worker made an absolutely terrible script. I'm probably gonna fire him. So he also made this really bad slide. It's a lot of gibberish, but pretty much what it means is that there's a way such that we can account for the other guy coming. Here's our 7 urinal system, okay? I'm just introducing a new thing, so it's more engaging for my example. So here's scenario 1 in our 7 urinal system. We have a guy in slot 3, 1, and 6 and anyway. So you can see the diagram. I don't have to say it out loud. So you could go to any of the slots 2, 4, and 5. Where are you going to? So let's test out each scenario, right? Let's call the solution 1. And when the other guy comes, he's going to go to slot 5. That's only reasonable. Let's see solution 2, where it goes to slot 4. The other guy is going to want to go to slot 2. And let's see 5. And similarly, the other guy is going to slot 2. So now let's group all of these together into a slide. Okay? As you can see, I marked the other guy with cyan, and as usual, I put you as in green. We're going to actually be able to apply the distance optimizing value in this example, and by coloring it blue, I am showing you that we are actually indeed accounting for the other guy. I'm just going to very quickly do the math for you, and we find that solution 3 takes the cake. And this does actually make sense if you really think about it. Look at the picture for a long time. Solution 3 actually makes the most sense. So, alright, I'm done for today. If there's anything else you'd like to see, go say it in the comments. I don't know, I'm kind of running out of ideas. But anyway, make sure to like and subscribe. Yeah, but as always, though, here is the formula that we're actually going to use. It may seem a little complicated, probably because it is. But for now, let's just go have one last example to kick off this video. How about that? Let's introduce the small urinals, because that's more realistic for the real world. You know the small, really dingy urinals? Yeah, you know what I'm talking about. So let's start with scenario 1. Where would you like to go? Of course, you'd go to slot 1. Come on, even though it's a dingy urinal, you'll still want to go there. And now let's introduce another one. Here's the scenario, right? And you'd want to go to scenario 2. And then you may be asking, Adam, why are you going to scenario 2? You should go to slot 1, or you should go to slot 7. See, the reason why you're going to slot 2 is because when you do it, you're making sure that when the other guy comes, he's not going to either slot 1 or 3. Because remember how they're super small and dingy, right? The mysterious yellow liquid is going to spray everywhere, and they would not even want to dare go near 1 or 3. So they would go happily to slot 7. All right, well, that's it, folks. But remember, maybe the real formula was the friends we made along the way. Yeah, no, but in all seriousness, for all these examples, just go take a stall.